Alright guys, so what we're going to do now is we're going to look at some graphs of sinusoidal functions, and then what we're going to do is we're going to come up with the equation for the sinusoidal function using the graphs, and we'll use both sine and cosine as well. I'll look at the negative cases of them too. So this first graph I'm actually going to ignore. The picture when it was copied didn't come off quite as well. And you see this point right here has shifted to the left. So there's actually really no readable points that we can get off this. I guarantee you guys that when it gets to the point where you have to actually do assignments, all of the points will be very, very readable. So I'm just going to ignore this one for right now. And we'll move to number 2 here. So looking at number 2, what I'm going to do is I'm going to stick very, very consistent with the box method that I was using before. The first thing that we want to do is we want to be able to find one period of this graph. So there's a lot of different points I can go to, but one period is basically going to be where my image starts and where it stops at that exact same point. So the amount of time for one cycle. From there, we're going to go back to that box method that I did before. I said that was my starting point, so this will be my ending point. Now this will vary depending on the graph that you look at and the function that you're trying to come up with. I'm just grabbing one period and we'll look at it, and then from there we'll figure out what the function actually is. I then draw a dotted line through the middle of the graph, and another dotted line through the top, and a dotted line through the bottom of the graph. So let's look at what we've been able to figure out here. The middle to the top is what the amplitude is. So amplitude is going to be equal to 1. My middle line is equal to 1 as well, because my middle line is at that point 1 right there. From here, what else are we able to figure out? Now, phase shift, I'm going to ignore. Okay, so we'll ignore phase shift for right now. I will talk about that in a second. But the problem is the phase shift depends on which function I'm using. So the last thing that I'm going to do is I'm going to look at the period. So my period right here was, oops, my period right here was from 0 to pi. So my period is going to equal pi. If my period equals pi, that means that my b value is going to be 2 pi over period, or my b value is going to be 2. My a value from amplitude is 1, and my d value from amplitude is going to be 1. Now, a, d, and b do not change between cos or sine. So sine and cos, the a, b, and d values do not change at all. And that includes if I'm using the negative graphs for sine and cos as well. So what I get is I get my basic structure here, where y equals and y equals. So I'm going to have a, which is 1 sine, and then my b value is 2 bracket x, and I'm ignoring the c value right now, and then it'll be plus 1. And for my cos, it will be the exact same. So what we get is we get my base sine and my base cos right here. Now, for the phase shift, and this is where it kind of gets important. If you remember, my base sine graph started in the middle, and it went up, and then it went down. My base cos graph starts at the top, and then goes down. So, starting off with cos, because it works out easier in this case, I look for where the top of the function is. or that point right there. And we see that the top of the function in this case is, and I'll use blue for this, right there. That's where that point and that's where that top of the function is. So that means that my cos hasn't actually moved anywhere because it's starting on that y-axis. So it's just going to be x plus or minus, I'm just going to use 0, so we go x minus 0. Or it will equal cos 2x plus 1. Now, for my sine, what I'm looking for is I'm looking for where it goes to the middle and then works its way to the top. So I'll use green for this. I need to find where sine goes middle to the top. Now we always start at the y-axis and work our way right for when we're looking for the sine. So right here, I see that is the point where sine starts at the middle and then goes to the top. You may think, well, there's no point right there, but we remember that this breaks perfectly into quarters. So this point right here is pi by 2, and that point right there is going to end up being 3 pi by 4. So that means that x has moved 3 pi by 4 over to the right. Now, if you guys want, we can kind of play the same game by looking at the negative graphs. I'm just going to take a look at them right now. I'm going to quickly erase the blue and the green, and then I'm going to just reuse those colors for looking at the negative versions of these graphs. So, if I shift over here, my negative sign starts at the middle, and then it goes to the bottom. And my negative cos starts at -1, and then it goes like that. So for my negative sign, what I'm going to do is I'm going to look at when we go middle to bottom. So I look at my graph here, and here it goes middle to bottom. So that means if I wanted to look at the negative sign graph of this, again, everything else stays the exact same. I get negative sine 2, and then it's going to be x minus pi by 4, because it breaks into quarters, plus 1. Looking at my negative cos, we go from the bottom to the middle. So I go for the bottom to the middle at pi by 2. So my negative cos would be y equals negative cos 2 x minus pi by 2 plus 1. Moving on, we look at this bad boy right here. Now again, what I'm going to do is I'm going to figure out one period of this. So I grab my marker right here, and again, there's a lot of different places that we can start trying to find the period. I'm going to start up here, and I'm going to go down right there, and I'll use this to create my box. So I go beginning to end, and then I find the middle of this. We see the bottom is -6, the top is 0, so that means the middle is going to be at -3. My top is going to be at 0, and my bottom will be at -6. So from here, we look from the middle to the top, and the middle to the top gives me an A value that's equal to 3. So my amplitude is going to be equal to 3. The distance between there and there, we can clearly see it's 2 pi. So my period is equal to 2 pi, meaning my B value is 2 pi over 2 pi, which equals 1. And my D value is equal to -3. Again, we're going to hold off on figuring out what the b values are until I state which function I'm looking for. So now I get y equals, and I'll start with the sign, so we get 3 sine, and then my b value is 1, and then it's going to be x, and then we'll slot in that c value in a second, and then we'll get minus 3. And then I'll go y equals 3 cos, again 1, x, and minus 3. So another thing that's going to be important right here is if we look, that's 0, this is pi, so this right here would be pi by 4, that right there would be pi by 2, and that right there would be 3 pi by 4, just breaking this into the quarters that it is. The easiest one that I'm going to have to figure out off the bat would be my cosine. My cosine, you can see we've just shifted to the pi by 4 value right there. And so my cosine is just going to be x minus pi by 4. Rewriting this a bit more neatly will give me 3 cos x minus pi by 4 and then minus 3. Now, for my sine, with my sine, there's kind of 2 points that I could look at that I could get my sine off of. I could look at that point right there, or I could look at that point right there. Now, by convention, we tend to go for the first positive one. But both of them would technically be correct, so I'll write out the solutions for both of them. In my first case, sorry about that, I went too far. In my first case, if I look, that's just going to be pi by 4 to the left, so I could look at this as x plus pi by 4, which would give me 3 sine x plus pi by 4, and then minus 3. If I look at my other one, which is all the way up over right here, well, breaking this into quarters, that would give us 7 pi by 4. So, let's write that right there. That point is 7 pi by 4. So, if I was to look at this in its other definition, it would be y equals 3 sine x minus 7 pi by 4 because we're moving right, and then minus 3. Now again, both of these are correct. It just kind of comes down to which one you can more easily see. And again, usually we do look at this version of it right here. Now, if we want to continue on this, so let's say I want to look for the negative sine graph. My negative sine graph is just going to be right there, and that's going to be that magical point for my negative sine graph, where we'd have y equals negative 3 sine x minus, whoops, that minus went everywhere, x minus 3 pi by 4 minus 3. And my negative cos graph would start off at that bottom point right there, which would be 5 pi by 4. And we'd get y equals negative 3 cos x minus 5 pi by 4 minus 3. This video is getting a bit long, so I will take up the next 2 examples in the next video.